Exactly, this is the topic which we have dealt last class. Now we will work on the remaining part. Now let us take these questions. Now we will work on the motional part here. Now read the question carefully. Now here, a conducting rod of length L slides at constant velocity V on two parallel. You see here the term. What is mentioned here is constant velocity on two parallel conducting rails placed in uniform and constant magnetic field B perpendicular to the plane of the rails as shown in the figure. Resistance R connected between the two ends of the rails, right? Identify the cause which produces change in magnetic flux. Obviously, the rod PQ motion is responsible for the motion of the rod, undoubtedly. There is no other option, right? Now tell me, I have given you clear indication. Inward field, use right hand rule, Fleming's. Inward field, thumb is rightwards and central finger is upwards. So actually, from my perspective, the circuit is like this. This EMF is BVL and this is resistance R, right? Identify the direction of the current in the loop. Undoubtedly, this is how the direction of the current is. EMF induced in the loop. E is equal to BVL. That's all. Current is BVL by R. It's a simple case. Now we are dealing with a complicated case. We are dealing with a complicated case. What is that complicated case? Two long parallel. Read the question carefully, everyone. Everyone try to read the question carefully. After this, I will start next week models. Two long parallel horizontal rails a distance d apart. Now here in this case, every element has some resistance. Now see, that circuit and this circuit is more or less the same. The only difference is here you have R resistance. Current type. You are applying some force here. Everything is the same. Right. Now the current goes like this and parallel to this, you will have one more force. That is magnetic field force. Variable force. No, no. First of all, try to please understand what is magnetic field force. It is BIL. What is current in this? At any instant, if the velocity is V, EMF is BVL, and the total resistance is this. This is how this question is different from the previous one. Right. Right. Let this be equation 1. FB is BIL. Now let us try to analyze what is FB from this. B square, L square, V by R plus 2 lambda x. Remember, this is FB. Fine. Clear. Till this point, I have no doubt. Now, what is the free body diagram of the rod? The free body diagram of the rod is you are applying a force F. There is magnetic field force B and variable force, fortunately. And one more important point, a constant current I flows through the R. That is important. So you are applying force externally, which is variable. FB is a constant. Now you want the velocity of the rod as a function of x. F minus FB is mv dv by dx. Clearly, what is F? F is a variable force. And FB is B square L square V by R plus 2 lambda x, which is equal to mv dv by dx. Remember, in a question of this format, you need to understand a point. What is that? Current is a constant given in the question. You cannot question how, why, all these factors. They have given that. It's not your problem. They have clearly given that. Current is a constant. Now, what is your problem is to arrive to this point, how to manage this. For this purpose, let us study much more claritatively on what to do and how to do these areas. Perfectly conducting rod, fortunately. There is a uniform. I think find the velocity of the rod and the applied force F as a function of the distance x from the rod. Now you said one point here, FB is a constant. See, what is previous FB? When initially, is there any velocity? Is there any initial velocity? Why I am asking is, you said a constant current I pass through. So which means I is, I am assuming I is the data. So B square L square V by R plus 2 lambda x is BIL. Entire right hand side is a constant, which implies velocity can be given as current into R plus 2 lambda x by BL. Don't question me why. You have given I as the data, lambda as the data, x instantaneous position. Now I have done the first part of the question. Now please allow me to write this as dv by dx. When I am writing dv by dx, I'll get the first term goes because they're constant. So I'll get 2 lambda I by BL. You have two terms here. So clearly, F is B square. Yeah, Arya, you said right now B square L square V is a constant. B square L square is the entire thing. Just have written. Why I require all the terms again? Now, please tell me why I require all the term. You have given me current as a data. I will use that data. Why not BIL plus M? Now I will use V data, dB by dx data. You need to take the product of these two. Product of these two gives you what? 2 lambda I square by B square L square times R plus 2 lambda x. That's all. I have done the question. Boys and girls, please ask me if you have any doubt on this. If you have any doubt, ask me right now. Just raise your hand. I'll allow you. Any student. Bhagavat, I allowed it to unmute yourself. Tell me, Bhagavat, what is your doubt in this?
సార్ అది డైరెక్షన్ ఒకసారి ఎక్స్ప్లెయిన్ చేస్తారా సార్? మనం ఎఫ్బి ఇంకా ఎఫ్ డైరెక్షన్.
Are ikkada they have given, you see from the top end. You are seeing it from the top view. You have inward magnetic field. Right? Fleming's right hand rule. What is Fleming's right hand rule? It's moving rightwards. As it moves rightwards, what happens? As it moves rightwards, inward Fleming's left hand rule. Inward, thumb rightwards, central finger upwards. This is how the flow of current takes place. That's what Bhagavat.
Yes, sir. Understood, sir.
Right. Any doubt in this part, please ask me. Any doubt in this part, please ask me. Right. Right. The next question. This way I have done. This one also. Yeah. Try this. Wire loop. Dimensions given. You have A, B, all that. A long straight wire is arranged as shown in the figure. Okay, forget about for a while whatever the current that passed through this, that is not our headache. My point is very clear. What you would like to express here? First, you need to find flux. Only then you determine what is happening over here. Remember, certain part of the screen I want to take intentionally. Why I will explain. For example, if I take this as some A naught part, see, lower side also, I will have some A naught part. Of course, A naught is nothing but B minus A. Due to this current, Palvita, what is the direction of the current above the point which I have shown here? What would be the direction of current flow at the point which I have shown here? Any doubts? Anything else you would like to contribute for that? Right hand grip rule. So thumb is rightwards. The remaining four fingers are outwards. You have an outward field like this. And you have an inward field like this. How much flux you accumulate over this portion, the same flux you will accumulate in this portion, which means net is zero. जितना फ्लक्स उधर जा रहा है उतना ही फ्लक्स इधर को रहा है. Therefore, net is zero. So, therefore, you should work on only this portion. Only this portion. And that too entirely inward flux. So, that flux is minus of, sir, షాప్ మనకేసారా? నేను ఎవరిని పంపించాలి? నేను ప్రసాద్ చెప్పాను నా దగ్గర ఫ్యాకల్టీ లేరని. ఓకే ఓకే సార్, నీ క్లాసులో అన్న మళ్ళా చేస్తాను మీకు. రైట్. Now you take some distance x at this point. Mu naught by 2 pi I by x dx into b. This is the small flux in some portion over here. And that to inward flux. That to inward flux. So the total flux x is equal to b minus a to b. That is the limits condition. So you will get minus mu naught by 2 pi b I as of now. Log e b by b minus a. Why you got negative? I told you very clearly, this is an inward flux. That's an inward flux. I hope there is no issue till this point. Now you bring the current picture. The current is changing with the time. So the EMF induced is minus d phi by dt. Are in this plus mu naught b by 2 pi log e b by b minus a. All this is a constant stuff, not related to time. So when I do di by dt from the given data here, I'll get 10t minus 10. So I'll get 10t minus 10. Remember, this entire thing can be treated as a constant. the entire thing can be treated as a constant. So now I got EMF as some 10 beta because I need to replace it. This entire thing I am replacing with some beta. 10 beta times T minus 1. What this one exactly refers to? This exactly refers to x-axis, y-axis, EMF, time. At t is equal to 0, you have EMF minus 10 beta. At t is equal to 1, you have EMF 0. Thereafter, it's a straight line like this. EMF negative means the moment you see here, the current goes in clockwise sense. Positive EMF means anti-clockwise sense. That's the deal. So therefore, for t greater than 1, the current in the loop is anti-clockwise sense. Whatever the value you want, just substitute in that. Boys and girls, do you have any doubt in this? Any doubt in this? Palvita, have you understood this?
Yes, sir.
Right. Next, Geetika, have you understood? See, 24 participants are there in this class. Worst situation. Gaurav, I think you didn't attend the last class. Why?
Health issue, sir.
మరి హెల్త్ ఇష్యూస్ సీరియస్ చదువుకునే వాళ్ళు కూడా చెప్తే ఎట్లారా దర్శన్ లాస్ట్ క్లాస్ వచ్చావా నెక్స్ట్ ఈ అమ్మాయి రాలేదా నిధి ఈజ్ నాట్ దేర్ టుడే నేను సార్తో చెప్పించేస్తాను రా నాకు కొద్దిగా ఇబ్బందిగా ఉంది ఫాలో చేయటం వల్ల మీరు బాగుపడే లక్షణాలు నాకు కనిపించట్లేదు నెక్స్ట్ యా ప్లీజ్ ట్రై టు వర్క్ ఆన్ దిస్ క్వశ్చన్ ఫిగర్ షోస్ a setup with the two long conducting rails with the distance of separation L in a perpendicular to uniform magnetic field of magnetic induction B. A sliding rod Mn of mass M is placed on rails as shown. The rails are connected with the resistance R and the sliding rod is pulled with a constant external force F. If initially the sliding rod is at rest at t is equal to 0, find the velocity of the rod at any time t and the terminal velocity of the rod. What is that I need to see here is how is this arrangement? Now, how to write the source of EMF? It is an outward field. Fleming's right hand rule. Outward field, thumb represents direction of motion. Central fingers is from N to M, which means this is how you have the arrangement. Right. So the initial current is BVL by R. Now you are applying some force F. And remember, this is a constant external force. Now remember, you have PIL opposition. And at any instant, velocity is V. What is the force free body diagram of this arrangement? F minus BIL is m dv by dt. Right. Now with this I can write f minus b square L square by R times V is m dv by dt. dv by alpha minus beta V. It is of the form and dt. I can say alpha as f by m, beta as b square L square by mr. Right. Now it is already known to you how to handle this. 1 by minus beta log E alpha minus beta V by alpha minus 0, because at t is equal to 0, you have nothing. So from this I can write log E 1 minus beta by alpha V is minus beta t. Now, from this, you can manage lot of things. From this, you can manage 1 minus beta by alpha V is nothing but e power minus beta t. Therefore, V is alpha by beta times 1 minus e power minus beta t. See, what is terminal velocity? At t tends to infinite, V becomes alpha by beta. This is called terminal velocity, constant. What is alpha by beta? If I take alpha by beta, I will get f into r by v square L square. That is the deal. Now I am asking again, do you have any doubt in this question? Any student? Do you have any doubt? Aditya, do you have any doubt in this question?
No, sir.
Right. So these are all some basic models which I have done the discussion part thoroughly. All this. On the basis of Lenz's law, you may expect this question. If you drop a bar magnet in case A, the induced current in the coil as a function of time can be represented by the graph. Whereas in case of B, there is no current. In that case, the magnet goes down with an acceleration equal to acceleration due to gravity. Whereas in the first case, it will not go like that. Rather, it will go with an acceleration lesser than the acceleration due to gravity. It's a simple Lenz's law based theory question. If you have any doubt, please ask me on this. Any doubts, boys? Almost all these things we have done because it's in a separate, different book which I have done. Right. We'll move on to the next concept. That concept is induced electric field concept. Remember, till now, when I am discussing about the EMF, induced EMF, I said EMF induced is possible in two different ways. EMF induced is possible in three different ways. First way, motional EMF, purely translational. The second way, rotational EMF. Now the third way, coil is fixed and the flux linked with the coil changes with the time. Now you take such a situation over here. Take such a situation over here. What is that you are seeing here is a cylindrical region of space. This is all a cylindrical region of space in which you have a uniform inward magnetic field. You have an inward magnetic field, right? And this inward magnetic field is changing with the time in magnitude, right? That change is expressed as dB by dt is plus alpha. I am giving you increasing case, right? Now, what is the definition of induced EMF? You said right now, Faraday's law, EMF induced, this term is called EMF induced, is minus of rate of change of magnetic flux, right? Now you take the flux, you take one arbitrary circle like this. This is arbitrary circle. This is arbitrary circle. For this circle, flux is minus b pi r square. d phi by dt is minus dB by dt times pi r square. From equation 1 and equation 2, I can make it that E into 2 pi r is equal to dB by dt times pi r square. So at this point, E is plus alpha r by 2. Plus indicates that the tangent drawn at this point gives you an electric field. What are these electric fields? These electric fields are different from the electric field which we have discussed in electrostatics. Yes. Those electric fields which I have discussed in electrostatics are all conservative fields. Whereas this electric field, which right now I am discussing, is a non-conservative field. Why? Observe the lines of forces. In electrostatics, lines of forces are open curves. They start at a particular charge, say positive charge, and they end at infinite or they end at some negative charge. Whereas here you see closed. Starting point, ending point is the same. They are not conservative fields. Conservative fields means actually this should be zero for a closed path. But here it is not zero. So non-conservative electric field is also called as induced electric field. At a point inside, this is what you will use. At a point outside the system, you will use this relation. Why? Because E into 2 pi r is dB by dt times pi capital R square in that case. So therefore, that's what I have mentioned here. E into 2 pi r is dB by dt times pi r square. So E is alpha r square by 2r. Okay? They are also concentric circles again. Here also concentric circles. Here also concentric circles. Both cases closed circles. Both cases field is pakka non-uniform. Non-uniform and non-conservative. Right. Why it is a non-uniform? See, circular curved lines are not uniform. Uniform field means it should be straight line. Right. Now you imagine a space, a cylindrical region of space like this. A cylindrical region of the space filled with magnetic field. And dB by dt is positive, increasing flux. I told you my left hand and right hand thumb rules. Left hand thumb, you paste inside, you just place the thumb into the plane of the paper. Curl of the four fingers. The curl of the four fingers will give you some idea about what that induced electric field lines. I repeat, The curl of the four fingers will give you thumb into the plane of the paper. Curl of the forefinger gives you the direction of the induced electric field lines. So I took dB by dt is positive. Right. Hold on. Now I am taking a shape like this, a square shape like this. Square shape like this. In this, observe points, 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 D. Remember the point D, C, B, A are on a different circle. And the point F is on a different circle. For example, if I am taking this as a square of side A, for example. Right. Now, here OD becomes, in such a situation, OD becomes A by root 2 and OF becomes A by 2. Right. Now, if you notice in this, what you are noticing is that at this point, E is, our formula is inside alpha R by 2. Alpha R by 2. You are having here. Same I am going to use here. Alpha radius OD by 2. OD already A by root 2. ED is alpha A by 2 root 2. Hold on. What is EF? Same formula, alpha R by 2, alpha OF by 2, alpha A by 4. If you notice, the component of ED along the direction of F is ED cos 45. Along DC, component is uniform. How? See, what is ED cos 45? ED cos 45 is alpha A by 2 root 2 into 1 by root 2. Alpha A by 4. And this is EF. That's the deal. ED cos 45 is alpha A by 4, which is EF. Which means along the line DC, the component is uniform. Remember, this is true. So long the line DC is inside. And remember, they are symmetric. The center of square coincides with the center of the cylinder. And this is true only when this condition is allowed. Suppose if this is off the center, then conditions may vary. Next. You have a cylindrical region of space. Fine. And instead of a closed conductor, I have introduced something with a slit open. A slit part is open. Then what happens? dB by dt is varying according to this relation, plus alpha. Then what happens? Are no coil bitna patapoina. You will have the electric field lines. How are the electric field lines in this region of space? In this region of space, the electric field lines are concentric circles. Like this. What is the effect of these circles? These circular fields will drive electrons in the opposite sense. So all the electrons will accumulate at A to conserve charge. A positive charge will accumulate at B, which means if you create a slit, small gap between A and B, there won't be any current flow. But the end A and B are at different potentials. Because accumulation of charge takes place. I have clearly told you the reason. You can imagine as if that situation is equal to this. That situation is equivalent to this. Any doubts? So therefore, if you ask me what is the potential drop, I'll simply say E into 2 pi R. What is E? E is nothing but alpha R by 2. So alpha R by 2, alpha R by 2 into 2 pi R. That is the potential drop. Any doubts? You can ask. Right. Right. So this is a very important theory bit where you may expect to work on these questions at a later stage. Right. Now, everyone try to work on this. 1 minute. I am not satisfied with. Keep working on that question. Yes. This looks neat. Cylindrical region of radius R is filled with a uniform magnetic field B, as shown in the figure. A metal rod AB of length L is placed inside the field. You can see all that the arrangement. How to solve this question? Now you can see that you see triangle ACB. What is the area of this triangle? half into base L into height OC. All that is a constant. What is the flux in the loop which I have represented? Minus B into L by 2 into OC represent R square minus L square by 4. Right. What is the expression for EMF induced? Minus d5 by dt. This is because the rest everything is a constant. dB by dt times L by 2 R square minus L square by 4. dB by dt you have given as alpha. So alpha L by 2 root of R square minus L square by 4. Remember, this is the EMF induced in the loop. And it is a positive, means anti-clockwise sense. Which means if there is any current, possible current that might go through like this. In that case, A side is negative and B side is positive. If it is a source of EMF and the current is from A to B, obviously A side becomes a negative, B side becomes a positive. That's the deal. Any student having doubt on this, please ask me right now. Otherwise also, the electric, if you take the arrangement like this, for example, the example like this. Now you have C here, O here, and the rod is like this. And the rod is like this. Now clearly, so long the arrangement is like this, what will happen? The rod is like this, I said. The electric field line components are like this. So as I mentioned, negative charge is pulled opposite to the electric field. To compensate this, you will have a positive charge like this. That way also you can understand, right? Any doubt on this, please ask me right now. Induced electric field concept. If any student is having doubt, please ask me right now. Any doubts? Boys and girls? No one? Aditya, clear?
Yes, sir.
Right. This is also an important stuff. Try to work out on this question. What if the rod is like this? Try to work on this, everyone in the class. Which means I'll give you a clarity on this. Same question. I'm extending the rod. That's the deal. This is L. This is also L. So no idea about only thing I can give you is I can give you the angle here. Some phi. That's how you have. Okay. Now for this, what is the potential drop across the length of this arrangement? That is the only data available to you. Very simple. Already you have done one for half of the question here. This part you already done. Only thing is, this is the area enclosed. There are two EMFs here. EMF 1 already copy from the above. What is that? Alpha L by 4 under root R square minus L square by 4. This is the first EMF. What about the second EMF? What is the angle described by this area? The angle described by this area is, if it is 2 pi, you will have pi r square. If it is 5, how much area? It is a half phi r square. So therefore, alpha times phi r square by 2. That is the EMF. And that is the total potential drop across the rod. So if you ask me VA minus VB, I will tell as if it is alpha L by 4 root R square minus L square by 4. If it is VB minus VC is equal to, it is alpha phi R square by 2. Any doubts? So you take the sum, VA minus VC. It is nothing but alpha L by 4 R square minus L square by 4 plus alpha times phi R square by 2. Right. మహంత్ నేను ఎప్పుడు క్లాస్ పెట్టలేదనో నేను లింక్ పెట్టేశాను కదా, రాలేదా మీకైతే? మెసేజ్ పెట్టారు నాకు, పెట్టండి క్లాస్ పెట్టలేదని. ఇంకా
నిన్న వచ్చింది సార్ క్లాస్కి.
అదే రైట్, ఓకే. అంటే అప్లోడ్ చేసేసాను అనుకుని ఉంటా, పీసీ మూసేస్తే అది అయిపోతుంది. రైట్, దిస్ ఈజ్ ఆల్సో అన్ ఇంపార్టెంట్ మోడల్. ఐఎమ్ జస్ట్ రిమూవింగ్ దిస్, నాట్ రిక్వైర్డ్. Right. A very important question. This one, important in the sense, lot of times people will ask this question. Let me just see whether this thin non-conducting ring. Let me just see. Yeah, just let me just see. ఎందుకంటే that question, yes. ఒక్క నిమిషం. ఎందుకంటే నీట్గా లేదు ఇది. Everyone try to do this question. Very good question actually. 3 to 4 models are there. If you work on them, that's quite sufficient. Thin non-conducting ring of mass m. ఇవాళ నేను అసైన్మెంట్ పెడతాను. ఇవన్నీ రెడీగా ఉన్నాయి యాక్చువల్గా. నేను ఇప్పుడు ఈ అసైన్మెంట్ కూడా పెడుతున్నాను. ఒకసారి మన 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 గ్రూప్ పేరు చెప్పండి ఒకసారి. వాటిది అదే పేరు చెప్పండి అన్న ఒకసారి.
యూకే టాపర్స్ అని అంటారు సార్.
ఈకే టాపర్స్ అసైన్మెంట్ పెట్టేసాను నేను. మీరు వర్క్ చేసుకోండి. ఎస్, a thin non-conducting ring of mass m carrying a charge q can freely rotate about its axis. At the initial moment, the ring was at rest and no magnetic field was present. Then a uniform magnetic field was switched on, which was perpendicular to the plane of the ring and is increasing with the time according to certain law dB by dt is equal to alpha. Find the velocity, angular velocity of a ring as a function of time. It's a non-conducting and you have a charge. First, forget about the charge and all that picture. Basically, that's the ring. And it is in a region of switched on in uniform magnetic, any direction, no issues. I'm assuming inward direction. Switched on. Now this will generate electric field lines in this region. Then see field lines. That is how inward increasing. So what is the direction? This is how you will have the field lines directed. Now every element is, say you said that it's of radius A, right? Let us assume that A be the radius. At A you have E given by alpha R by 2. You know this. At every element of the ring. Here alpha refers to K. This is K, A by 2. Equation 1. Take one such element over here. Force is EQ. K A by 2 into mass and charge. Lambda A d theta. That is the force. Everywhere you have such forces. Everywhere. And these forces contribute to torque. F into A. So K A square lambda by 2 d theta is the torque. So finally, what is going to happen for you is K A square lambda pi. This can be written as K A square. Are bhaiya, lambda is charge per unit length. Lambda pi A is nothing but Q. Q term. You will have K A Q by 2. Just please confirm if I am correct or not. I repeat the part again. F into A. Here it is A cube. One A term is missing. Okay, A cube. So A square, K A square Q by 2. All this is the torque of E, induced electric field. Now this will give you, it is acting for time t, for example. This will give you angular acceleration. So tau into t is I omega. Angular impulse is change in angular momentum. So K A square cube by 2 is MA square ring into omega. So implies omega is K cube by 2m times t. There is an expression for angular velocity as a function of time. Any doubt on this? Please ask me right now. Boys and girls, If you have any doubt on this, please ask me right now. Else, I'll proceed for the next concept. Any doubts? Palvita,
సార్ టౌ ఈజ్ ఈక్వల్
అడగరా.
సార్ అది టౌ ఈజ్ ఈక్వల్ టు ఐ ఆల్ఫా చేసి ఆల్ఫా
అలా
కనుక్కొని
కూడా
ఒమేగా
చేసుకోవచ్చు.
కనుక్కోవచ్చు సార్.
ఆల్ఫా ఇస్ ఒమేగా ఇజ్ ఈక్వల్ టు ఆల్ఫా టీ కూడా చేసుకోవచ్చు. అంటే
ఓకే
ఇది
ఓకే ఓకే
కాన్స్టెంట్ టార్క్. నువ్వు చూసినట్లయితే దిస్ ఇస్ ఎ కాన్స్టెంట్ టార్క్. కాన్స్టెంట్ టార్క్ కి సింపుల్ గా టౌ ఇంటూ టీ ఐ ఒమేగా వేసేయచ్చు. లైక్ కాన్స్టెంట్ ఫోర్స్ అయితే ఎఫ్ ఇంటూ టీ ఎంవి చేసినట్టు.
ఓకే
దట్స్ వాట్ ఐ ఫాలో. దట్స్ వాట్ ఐ ఫాలో.
ఓకే
రైట్. నెక్స్ట్, సో అది తీసేసేయండి. One more question that I wish to discuss. This is also a very good question. Even if I remember, such a question is there in NCRT also. Right. Go ahead. Work on this question. Remember, here it is suddenly. Half of the question I have already done. Half of the question already we have done here. I'll post that solution and this question simultaneously. Keep on. I think you'd have tried this. This is also an easy question, practically. In fact, half of the question you already done. Now, what is the torque that you got it about? See, please try to understand the torque of electric field. Here, please try to understand in the place of K, you try to write dB by dt in the place of K. In that case, the torque becomes dB by dt times charge Q, radius also not mentioned, a square Q by 2. That is the torque. Now, tau dt is nothing but dB a square Q by 2. Now, do integration on both the sides. Integral tau dt is I omega. And this is delta B. Are you switched on? So, final is B. B a square Q by 2. Okay, you want omega. M a square omega is B a square Q by 2. So, omega is nothing but PQ by 2M. That's the deal. I'm asking again, do you have any doubt in this question? Any student? Any student in the class? Palvita, any doubt?
No, sir.
Nidhi, why you didn't attended during the first part of the class?
Sir, I had net issues.
Aditya, okay na? Next question వెళ్ళిపోదామా?
Yes, sir.
రైట్. తీసేస్తాను, ఇది ఆల్రెడీ చేశాను కాబట్టి. అంటే క్వాలిటీ బాలా ఇది అండ్ సొల్యూషన్స్ ఉన్నాయి. ఎస్, దిస్ ఈజ్ మై ఫేవరెట్ క్వశ్చన్. లింకింగ్ అసలు మీరు ఐఐటి క్వశ్చన్ పేపర్ ఈసారి చూస్తే ఎవ్రీ క్వశ్చన్, అరే నేను సెంట్రల్ ఆఫీస్లో సెకండ్ పేపర్ డిస్కస్ చేసేసాను. మొత్తం వీడియో లెక్చర్ అది, అంటే ఫిజికల్గా డిజిటల్ బోర్డ్ మీద చెప్పిస్తారు. ఫస్ట్ ఇది కూడా ఉండొచ్చు, వేరే వాడు చేయిస్తా ఉన్నారు, వాడు చేయకపోతే నేను చేయాల్సి వస్తుంది. సెకండ్ది అయితే నేనే చేశాను పేపర్. మీకు తర్వాత ఏప్రిల్లో పెడతాను నేను అది పేపర్ డిస్కషన్ కంప్లీట్గా. ప్రతి క్వశ్చన్ 2 to 3 కాన్సెప్ట్స్ ఇంటిగ్రేట్ చేశాడు. మీరు ఇలా సీరియస్గా లేకపోతే మీరు ఇంచుమించు చదవటం కష్టం, మీరేం చేయలేరు. సీరియస్గా చదవగలిగితేనే మీరు ఏదైనా రీచ్ కాగలుగుతారు. రైట్, నోట్ దస్. స్టార్ట్ వర్కింగ్ ఆన్ దిస్ క్వశ్చన్. You study the entire question. Don't come to one single conclusion. Non-conducting ring of mass n and radius r has a charge q uniformly. అరే లాస్ట్ 2 క్వశ్చన్స్ ఏంటో ఈ క్వశ్చన్ కూడా అంతే. కాబట్టి మనం ఒక ఆస్పెక్ట్ వాడుకోవచ్చు ఇక్కడ. dB/dt టర్మ్ వాడుకోవచ్చు. Placed on a rough horizontal surface such that the plane of the ring is parallel to the surface. Vertical magnetic field B is equal to B naught T square Tesla is switched on. After 2 seconds from switching on the magnetic field, the ring is just about to rotate about the vertical axis through the center. అక్కస్తాగా ఇంత డైరెక్ట్ నేను చదవలేదు. ఏం జరుగుతోంది ఇక్కడ? ఇప్పుడు ఇందాకదే టార్క్ వాడుకోవచ్చని చెప్పాను నేను. టార్క్ ఈస్ మీరు చూసారు కదా. One. Here dV/dt is 2B naught. Now remember earlier torque is a constant. Here torque is not the constant. In fact, it is B naught T A square Q. That is about the torque. Someone please confirm whether you are comfortable with this part of my derivation, yes or no. Right. This is the torque part. So what is actually happening? Earlier, all the rings moved. Why these are not moving? Because you study at this point, this electric field will tend to rotate it in anti-clockwise sense. But friction exists everywhere. Everywhere there is a friction. And the friction force at an element is mu. See, normal reaction is distributed throughout. Normal reaction is distributed throughout. And that normal reaction is mg/2 pi a. That is normal reaction per unit length. Mu times mg/2 pi a into a d theta. Mu times mg/2 pi a d theta is a normal reaction part. And into a gives torque. Total torque of friction is integral a df. This is nothing but mu mg/2 pi a times 2 pi. But this is now mu mga. And remember, this acts in clockwise sense. This one acts in clockwise, anti-clockwise sense. At some point of time that you mentioned at t is equal to 2 seconds, the torque rotating balances with the torque of friction. So which means B naught 2B naught A square Q is mu mga. What do you want? Friction coefficient. Yes, I have the value of friction coefficient. From this mu is 2B naught AQ by H. That's the deal. The first part of the question is done. B is 2B naught AQ by MJR. If they have given capital Q, convert it. If they have given capital R, convert it. Nothing wrong. In the place of A, you use, I'm using A as capital R, Q place, you use a capital Q. No issues, man. You need to find out what is required here. So now find the frictional coefficient mu between the ring and the surface. That's the first question. I comfortably determined that. What is happening after 2 seconds? After 2 seconds, what is happening? The rotating torque dominates over friction. So what is at for t greater than 2 seconds, net torque will be greater than 0, and that is in anti-clockwise sense, which means now you have understood one thing is very clear from this question. The effect of tau friction is tau b at t is equal to 2. Thereafter, friction is constant. So therefore, I can write like this, control. Now I can write like this. B naught t a square q minus b naught 2 a square q. I'm not cheating you. You agreed with me here. That is a net torque. And that torque is I alpha. I d omega by dt. Right. What do you want? Then find the angular velocity of the ring just after switching off. Means at t is equal to 4 seconds. Right. Now everything is common. B naught a square q t minus 2 dt integration is integral I d omega. In this, both the sides, you are doing integration. Now, B naught a square q at t is equal to 2 seconds, omega is 0. You need to do the integration from 2 to 4. Don't forget that. And omega. B naught a square q, okay, 4 square minus 2 square by 2 minus 2 square is m a square omega. Array are cancel. So therefore, finally, omega is b naught q by m times 16 minus 4, 12 by 2, 6, 6 minus 4, 2. Omega becomes 2b naught q by 2b naught q by m. Remember, at t is equal to 4 seconds. I just want to take a break over here because a lot of journey I have done. Students, it's up to you now. Tell me, do you have any doubt on this? Do you have? Aditya, follow in a
Yes, sir.
Sahasra, follow in a
Yes, sir.
Palvita, follow in a
Yes, sir.
Right. Geetika,
Yes, sir.
right. Bhargav, you can be Sakla.
Yes, sir.
Right. Right. Mahant Ede, Mahant, any doubt? Mahant got Udri said. Bhagavat,
Yes, sir. Understood.
right. What is the third part? Find the angle rotated by the ring before it comes to rest after switching of the magnetic field. ఏంద్రే అసలు ఎందుకు శాస్త్రాలకు ఎందుకు మోసంలోకి తీసుకురావాలి మళ్ళీ ఎందుకు ఆపేయాలి? Now it is nowhere related to this question. Now this is the situation where the ring is rotating with an angular velocity, some angular velocity omega, and all of a sudden you have switched off. So friction dominates now. Now we know what is frictional torque. Yes, I know what is frictional torque. And fortunately, this is a constant. Frictional torque is constant, and frictional torque is same as 2b naught a square q, and this is a constant. మహంత్ ఇప్పుడే చెప్పాను, కాన్స్టెంట్ కి మనకు ఒక ఆప్షన్ ఉంది. ఏంటది? If it is a constant, you have one option. Torque is a constant, you have one option. What is that? ఇప్పుడే చెప్పాను, ఇవాళ చెప్పాను నేను. పల్విత ఏం చెప్పాను? కాన్స్టెంట్ అయితే ఏం చేయొచ్చు అని చెప్పాను. జస్ట్ టుడే ఓన్లీ ఐ హావ్ టాట్ యూ దట్. అరే యార్, నో వన్ ఈజ్ ఆన్సరింగ్ ఇన్ ద క్లాస్. Nidhi, if it is at constant torque, we have an advantage. If it is a constant force, we have an advantage. Yes.
సార్ యాంగులర్ మొమెంటం కన్సర్వేషన్.
Tau into t is equal to change in angular momentum రాసేయచ్చు. ఇక్కడ మీరు చేయాల్సింది ఇక్కడ నెగటివ్ టార్క్ అవుతుంది. టౌ ఇంటూ టీ ఈస్ డెల్టా ఎల్. సో అరే ఆ టౌ కష్టపడి రాసుకుని ఎక్కడ ఒక్క నిమిషం. అదే టార్క్ మైనస్ 2p naught a square qt is final angular velocity 0 because comes to rest. Initial angular velocity mr square omega, which is nothing but mr square omega, which is nothing but m cancel. So finally 2b naught a square qt is 2b naught q a square. Or yeah, 3 terms. 1 second after switching off. Don't take that as 1 second. If it is 1 second after switching off. What is the question that you want? What is the question that you want? Angle rotated by the ring before it comes to rest after switching off the magnetic field. Okay, unnecessarily, but okay, fine. Multi-correct answers, so they may use it for some other purpose. Right. You want angle rotated? Oh, no issues. Even now also torque is constant. Torque can be written as I omega d omega by dt. Use this minus 2b naught a square q is m a square omega d omega by dt. Now do the arrangement properly. And this is omega is decreasing term. Don't forget that. Minus 2b naught q by m d theta is omega d omega. Okay, no issues. So by the time the entire thing comes down, initially it is omega naught. Let this be omega naught. Finally 0. Theta is 0, finally theta. So therefore minus 2b naught q by m theta is, yeah, please tell me, omega or half omega naught square, which is nothing but 4b naught square q square by m square. Right. Minus cancel on both the sides. B naught q by m, b naught q by m cancels on both the sides. 2 also gets cancelled if I look at properly. So finally theta, what you got is, what is that the value of theta you got? You want theta, don't forget that. Theta, what you got is b naught q by m. If I'm not mistaken, that's the fact. That is the answer. If you are not interested, okay. B naught B naught q by m can also be written as B naught q mu g by 2a. That way also you can write. It is up to you now. This is how you need to solve. I am telling you, damn sure question this one. Don't take it easy. It's a damn sure question. Now also I am asking. You have any doubt, please ask me. It's a very, even NCRT also you have such question. Now, please tell me, do you have any doubt, any level, anywhere? Please ask me. Boys, may I confidently proceed further? Palvita, may I proceed further?
Yes, sir.
Right. Right. Basic theory part I have done for this week. Only thing left is practice. I have posted the questions to you. Go through. Today is Thursday, hardly. Sunday, you will have cat and cat together. Right. Yeah, please answer one. Shows two circular rings of radii A and B. Okay, fine. dV by dt figure shows the pattern obtained by. What to find in this? The question is not properly pasted. Figure A shows two circular. Okay, fine. One more line is missing, if I'm not mistaken. Let me identify that. Yeah. Where did I miss this? Hello? Very good. ఓకే. అడ్రస్ కరెక్ట్‌గా వచ్చిందా? ఓకే. లాస్ట్ టైము అది కొంచెం ఇబ్బందయింది. హ్మ్. హ్మ్. ఓకే. రైట్. ఓకే. Give me some time here. One line I think is missing. One line at least. Yes. Not one line. In fact, one paragraph as a whole was missing. How can we do that? An entire paragraph was missing in that. ఇట్ ఈస్ అ ఒలింపియాడ్ క్వశ్చన్. అరే ఇప్పుడు మొన్న ఐఐటీలో కూడా ఒలింపియాడ్ క్వశ్చన్స్ ఇచ్చారు. ఆ పాత్ ఫైండర్ లాంటి మోడల్స్ పడ్డాయి. దీని క్లాస్లో డిస్కస్ చేసిన క్వశ్చన్ యాజ్ ఇట్ ఈస్గా వచ్చింది. యా, ఎస్, నో యూ ప్లీజ్ కంప్లీట్. All the three arrangements are placed perpendicular to the plane of the loops. If the resistance per unit length of the wire is lambda, then determine the induced currents in each case. Simple. If I take case A, all that discriminates this part is area. Area as far as my point of view. Area, according to me, in this case is pi times a square plus b square. Pi times a square plus b square in this case. A. So therefore, in the case of source of EMF, it is nothing but dB by dt times pi a square plus b square. In this case, it is nothing but current is nothing but EMF by resistance. dB by dt is K. That's what I have given. K into pi into a square plus b square times. Now, what is the length? What is the length of the total part? 2 perimeters. 2 pi times a plus b into lambda. Lambda means resistance per unit length. Now, tell me finally what is this going to be? K times a square plus b square by 2 lambda times a plus b. That is the current induced in the case of right. Now, what about option B? You take option B. See, in this case, the effective area that you can see is pi a square minus b square times dB by dt, which is nothing but k into pi into a square minus b square. So, no, d5 by dt if I am writing, d5 by dt if I am writing, right. Next, any doubt till this point? Yes. Now, what about the current?
సార్ అక్కడ బిలో మధ్యలో చిన్న గ్యాప్ ఉంది కదా సార్, ఏరియాలో చేంజ్ ఏం రాదు.
పెద్ద పట్టించుకోవాల్సినంత గ్యాప్ కాదు అది. అది స్మాల్ లూపే కాబట్టి పెద్ద పట్టించుకోవాల్సినంత గ్యాప్ కాదు అది. స్మాల్ లెంగ్త్ అని. అంటే మీకు అదేది చూపించలేకపోతే ఎలా అర్థం అవుతుంది? ఇప్పుడు ఆ లెక్కన సిలో ఏం కనిపించింది నీకు అప్పుడు గ్యాప్?
ఓకే
అదే అంత పెద్ద పట్టించుకోవాల్సినంత గ్యాప్ కాదు.
ఓకే సార్.
రైట్. ఒకవేళ అది కాకపోయినా అది ఆ టర్మ్ వల్ల మన ఎఫెక్ట్ కాము అట్లీస్ట్. రైట్. ఇప్పుడు కరెంట్ ఏమవుతుంది ఈ కేసులో? కే ఇంటూ పై ఇంటూ ఏ స్క్వేర్, అన్నిటికీ డినామినేటర్ కాన్స్టెంటే. ఎందుకంటే పాత్ ఏదైనా అదే కదా. 2 పై టైమ్స్ ఏ ప్లస్ బి లాంబ్డా కే ఇంటూ ఏ మై, ఐఎమ్ అజ్యూమింగ్ ఏ ఈజ్ గ్రేటర్ దాన్ బి by 2 lambda. That is B. Any doubt in B? Option B. Boys and girls, do you have any doubt in option B? Option B. Option B and C are same because there is a flip over here. So the EMF contribution in A and the EMF contribution B drives current in opposite sense. యాక్చువల్గా ఏ ఇంటెన్షన్ అది కాదు, ఇది కాదు ఏ ఇంటెన్షను. ఏ ఇంటెన్షన్ ఇది. That is the intention of A. Small gap. Now what about C? Same, I told you, no? So net flux, are B and C copy paste. B and C copy paste. Same, everything is the same. Now I am asking you to still have any doubt. This is one of the Olympiad question. In fact, you will have this one in Irido book also. Irido book lo kuda undi question. I am asking you again, do you have any doubt?
No, sir.
Right. Palvita, do you have any doubt?
No, sir.
Right. Geetika.
No, sir.
Right. I am moving on to the next question. It's a very famous question actually. A very famous question. I think we have done a similar question last week related to the force. Now, this week, your work is on determining the induced EMF in that. Your major work lies current increases at a steady rate. Okay, fine, small circular coil of radius 10 power minus 3 meter area. I think their intention is almost the same. It's not like ఇక్కడ మీరు నోటీస్ చేస్తున్నట్లయితే 1 meter is much greater than 0.1 meter. Radius at 10 power minus 3. So in this condition, mostly field inside circle is uniform. Now, what is the flux at this point of time? Minus B into area A. Minus mu naught by 2 pi I by 1 meter into pi into 10 power minus 6 R square. Cancel this. Mu naught by 2 into 10 power minus 6 into I. Can someone please explain why there is a minus sign? When I have written phi is equal to minus BA, why I have written minus sign there? Anyone in the class? Prayer, no one is responding.
Sir, decreasing flux కదా sir.
Kadu. That is not the reason. Inward flux అక్కడ ఉంది.
Okay.
Right hand side of the current carrying conductor కాబట్టి inward flux. ఇంకా నేను ఈఎంఎఫ్ దాకా రాలేదు కదా. మైనస్ d5 by dt. This is plus mu naught by 2 into 10 power minus 6 into di by dt. di by dt already you know I is 2.5 into 1 plus 2t into 10 power 3 amps. di by dt is 5 into 10 power 3 amps. Right. Now what is happening over here? This is mu naught by 2 into 10 power minus 6 into 5 into 10 power 3. That is all EMF. Direction and current I is EMF by resistance. Mu naught means 4 pi into 10 power minus 7 minus 6 plus 3 into 5 by 2 times. You said one more point. Resistance of the loop is 5 into pi into 10 to the power of minus 4. 5 cancel. 2 cancel. Pi cancel. 2 into ఇక్కడ న్యూమరేటర్ ఎంత అయింది ఇప్పటికి మైనస్ 13 plus 3 minus 10 plus 4 minus 6. 2 into 10 power minus 6 amps. Positive. So the current in the loop is anti-clockwise sense. Anti-clockwise sense. Boys and girls, any doubt, please ask me. Any student having doubt in this, please ask me. Sure.
Yes, sir.
Right. So the other problems, all these are majorly, we will take up this question today. మన ఎగ్జామ్స్ లో రిపీటెడ్ గా అడిగే క్వశ్చన్ ఇది. A particle having charge Q is placed at a point P outside the cylindrical magnetic field region, where the uniform magnetic field is perpendicular to the plane of the figure in a cylindrical region of radius R. The magnetic field is increasing right? They are moving in two directions, one along OP, the other along PQ. See, remember, so long you travel in this direction, there is no work required. Can someone tell me what is the reason for this? If I am traveling along the direction radially, I don't require to do any work. Why? Because all the time for induced electric fields, our direction is perpendicular. Our line is perpendicular at every point of the induced electric field because they are all concentric circles. Your direction is normal. So perpendicular. Everywhere, wherever you are, field is perpendicular, so it does no work. The first part is 0. Second part also, you can do it simply. Remember, this is the region, and you are here and going to infinite, which means the arc that contributes EMF source is this one. The arc that contributes EMF source is this part. So therefore, EMF is 1/4 pi r square times dB by dt. So therefore, 1/4 times pi r square dB by dt is beta. So beta by 4 pi r square. Remember, that is EMF. You want work done. This is potential difference. Work done is EQ. So PQ pi r square by 4 is my answer. BQ pi r square by 4 is my answer. Right. But still, if you అరే నేనే మోసం చేయట్లేదు మిమ్మల్ని. ఇప్పుడు ఇదే క్వశ్చన్ ఇందాక ఇక్కడ చెప్పాను మీకు. ఇదే క్వశ్చన్ ఇక్కడ చెప్పాను మీకు. ఇక్కడ కూడా నేను అదే కదా చేసింది. Across these two potential difference వచ్చేసి కాంట్రిబ్యూషన్ ఆఫ్ ఓన్లీ దిస్ లూప్. ఇప్పుడు ఈ సీని మీరు ఇన్ఫైనైట్ దాకా తీసుకుపోతే ఏమైపోతుంది? ఆ సీని ఇన్ఫైనైట్ దాకా తీసుకుపోతే మీకు యాంగిల్ ఏమైపోతుంది అక్కడ మన క్వశ్చన్లో, రైట్ నో ఆఫ్ ద ప్రజెంట్ క్వశ్చన్లో? ఈ క్వశ్చన్లో
90 degrees.
90 degrees కదా. అప్పుడు కాంట్రిబ్యూట్ చేసేది లూప్ ఇలా తీసుకోవాలి. అప్పుడు లూప్ ఎట్లా తీసుకోవాలి? ఇన్ఫైనైట్ ఇన్ఫైనైట్. దీనిలో ఫ్లక్స్ చేంజ్ కాంట్రిబ్యూట్ చేసేది ఈ సెగ్మెంట్. టిల్ దిస్ పాయింట్ ఎనీ డౌట్స్? పల్విత, గీతిక, నో వన్ ఈజ్ రెస్పాండింగ్ యాక్చువల్లీ. ఆన్లైన్ క్లాస్ కదా ఇది. నిధి, I'll check only for 2 days. Saturday also, if required, I'll take the class online only, if possible. Whereas on Monday, it's a physical class again, irrespective whatever happens to the exam. Right. So I'm closing the class. Make sure you do the homework properly.
Yes, sir.
Anything else you would like to add?
No, sir.